Hi everyone, welcome back. In this video, we are going to look at Vista's multi-layers biome blending. In the previous tutorials, we already learned how to set up a Vista manager, create biomes, and build terrain graphs. So in this video, we will not repeat those steps. Instead, we will focus on one question. When two or more biomes overlap, how should Vista combine their terrain, textures, holes, trees, grass, rocks, and other objects? That is what biome blending controls. I have prepared this demo scene to show most of the blend modes in one place. You can find it at Assets, Pinwheel Studio, Vista, Personal, Samples, Scenes, Demo Multi-Layer Biome Blending. Everything used in this scene is packed with the asset, including the biome graphs. So after watching the video, you can open the scene, select each biome, and inspect the graphs and settings yourself. In this video, we will not explain the full graph flow. We will focus on how the biomes are layered and how their blend settings affect the final terrain. Before we touch the settings, let's understand the basic idea. Vista does not use one single blend mode for everything. A biome can output many kinds of data. It can output height. It can output terrain textures. It can output holes. It can also output populations such as grass, trees, details, objects, and custom buffers. These are very different kinds of data, so they should not always blend in the same way. For example, blending two height maps is different from blending two forests. For height, we may want the taller mountain to win. For vegetation, we may want one ecosystem to replace another one. Or maybe we want both ecosystems to exist together. This is why Vista gives us separate blend options for different channels. Just remember, each biome has a mask, each biome has an order, and each output channel has its own rule for how it blends with the biomes before it. Let's select one of the local procedural biomes in the scene. In the inspector, we can find the Blend Options section. Here we have settings for height, textures, holes, mesh density, and population. There is also an option called Use Transform for Height Blend. We will go through these settings one by one, using this scene as a visual example. Instead of explaining every mode one by one, let's walk through the biomes in this scene. This is usually the easiest way to understand blending. Before we go into each biome, let's make the scene easier to read. I will disable all biomes except mountain biome. Then I will regenerate the terrain. Now we can see the base terrain by itself. After that, we will enable the other biomes one by one, regenerate, and look at what each biome adds to the final result. This way, the effect of each blend setup is much easier to see. First, let's select Mountain Biome. This is the base mountain biome for the scene. It creates the main terrain shape, the main terrain textures, and the base population. For this biome, the blend modes are simple. Height, hole, texture, and population are all set to replace. Because this is the base layer, it does not need to do anything special. It gives us the first complete version of the terrain. Later biomes can then modify this result, add details on top of it, or take ownership of smaller areas. So when you are making your own scene, this is a good starting point. Create one main biome first and keep its blend modes simple. Now let's look at Sand Dunes biome. This biome is more selective. Because this biome represents sand, I do not want it to cover the whole masked area. I only want the sand to cover the hollow part of the base mountain terrain. So the sand should fill the lower hollow area but should not paint over the higher mountain parts around it. For height, this biome uses Keep Higher. Keep Higher compares the current height with this biome's height, then keeps the higher value. So the sand dune shape appears only where it rises above the existing terrain. Also notice that Use Transform for Height Blend is enabled. This means the biome's Y position and Y scale contribute to the height blend. So if I move the sand dunes biome up or down, or scale it vertically, I can control how much the dunes rise into the hollow area. That makes the blend easier to art direct directly in the scene view. Now look at the texture mode. Texture is set to Height Win. This means the sand texture only appears where the sand biome won the height blend. This is important. Without Height Win, the sand texture can spread across the whole biome mask. If I switch Texture Blend to Replace, you can see the sand bleeding into areas where it should not appear. I will set it back to Height Win. Population is also set to Height Win, so any population from this biome also follows the area where the sand height wins. This keeps the terrain shape, texture, and objects visually connected. So the practical rule here is, when a biome uses Keep Higher or Keep Lower for height, use Height Win for texture or population if those outputs should follow the winning shape. Next is Oasis Biome. This biome uses a normal Replace setup. Most of its blend modes are set to Replace, so the Oasis takes ownership of its masked area. Inside the Oasis area, its terrain, textures, and population are blended in as one clear biome. This all-replace setup is very practical when you just want one biome to gradually transition into another biome without thinking too much about special rules. The soft transition here comes from the Biome Mask Graph. A biome mask graph is a small graph that adjusts or filters the biome's coverage mask. For example, it can add noise, blur the edge, or reshape the mask so the transition looks more natural. If I unassign the biome mask graph and regenerate, the Oasis transition becomes hard and polygonal. Now I will assign the biome mask graph back and regenerate again. With the mask graph restored, we get the original smooth transition back. So, when you just want a gradual transition from one biome to another, use Replace for all blend modes, and a biome mask graph can help with higher quality transition. Next, let's select Mound of Earth. This biome is used to add a raised landform on top of the base terrain. The important setting here is the Height Blend mode. Height is set to Raise. That means this biome does not simply replace the mountain terrain. Instead, it adds its height into the area covered by the biome mask. This is useful when you want a biome to behave like an extra terrain feature. For example, you can use this for mounds, ridges, raised patches of land, or any shape that should sit on top of the base terrain. Also notice that Use Transform for Height Blend is enabled. So the biome's transform in the scene matters for the height blend. If we move or scale this biome vertically, it affects how strongly this raised shape appears in the final terrain. If this biome used lower instead, it would push the terrain down inside the mask. That is useful for dents, cuts, trenches, riverbeds, or any feature that should carve into the base terrain. The other blend modes stay simple here. Texture is Replace, Whole is Replace, and Population is Replace. Currently, This mound biome does not output any vegetation or objects, but because its population blend mode is set to replace, it wipes out the trees and grass from the base biome underneath. If I set population blend mode to coexist, the trees and grass from the lower biomes can grow on this mound too, making it feel more like a hidden place. So the main lesson from this biome is use raise when the biome should add height to what is already there. Lower is the opposite. Now let's look at the cave entrance biomes. These are good examples of hole blending. The hole blend mode is set to max. Max means holes accumulate. If one cave entrance cuts a hole, that hole stays. If another cave entrance cuts another hole, that one also stays. This is useful when you have several biome instances that all need to contribute holes. If we used a normal replace style here, a later biome could potentially overwrite the hole result from an earlier one. Let me demonstrate that. I will set hole blend mode to replace and regenerate. Now the cave entrances do not preserve each other as well. One biome can overwrite the hole result from another biome in the overlapping area. I will set hole blend mode back to max. With max, each cave entrance can safely add its own opening. Population is set to coexist. That allows the cave entrance biome to preserve the trees, grass, and other population from the surrounding biomes. Now let me also switch population blend mode to replace. When population is replace, the cave entrance biome claims its mask area. That can remove trees, grass, or other population from the biomes underneath. For this cave entrance, I want the entrance details to be added on top of the existing environment. So I will set population blend mode back to coexist. So for cave entrances, tunnels, and terrain cutouts, this setup is a good pattern. Use hole max to preserve all holes. Use population coexist if the entrance should preserve details of the existing biome. Now let's select the flower patches. These biomes are different from the main terrain biomes. They are not meant to reshape the mountain. They are not meant to replace the whole ecosystem. They are small overlay biomes. For these flower patches, population is set to coexist. Coexist means the flowers are added on top of what is already there. They do not erase the grass, rocks, or other population from the base biome. This is useful for details that should layer into the scene. Flowers are a good example. Small rocks, debris, mushrooms, grass clumps, and decorative objects are also good examples. Their main job is population. So the lesson is, use coexist for overlay biomes that should add objects without removing the existing biome. At this point, we can read the whole scene as layers. Mountain biome is the base layer. Sand dunes biome uses keep higher, then uses height win, so its texture and population follow the winning dune shape. Oasis biome replaces its local area as a normal biome. Mound of earth raises part of the terrain. Cave entrance 1 and cave entrance 2 preserve their holes with max and add entrance details with coexist. Flower Patch 1 and Flower Patch 2 coexist with the existing population. This is the main workflow I recommend when setting up your own scene. Don't start by memorizing every blend mode. Start by asking what each biome is supposed to do. Is it the base terrain? Is it adding height? Is it only visible where its terrain shape wins? Is it replacing an ecosystem? Is it adding objects on top? Is it cutting holes? Once you answer that, the blend settings become much easier to choose. One more behavior is worth mentioning. A biome graph does not have to output every channel. For example, an overlay biome may only be used for population. Another biome may only be used for holes. If a biome does not produce a certain output, Vista treats that as intentional. The Vista Manager can then decide whether the terrain should keep existing data, clear it, or populate it with the blended result. By default, missing output channels are set to clear. That means if no biome outputs a channel, that part of the terrain data is cleared back to a blank state. The important point is simple. Make each biome output what it actually needs to control. You do not have to force every biome to output everything. That is the overview of Vista's multi-layers biome blending. The main idea is to look at each biome by its role, then choose the blend settings that match that role. You can open Demo Multi-Layer Biome Blending in the package and inspect each biome directly. The graphs are included too, so feel free to open them and explore how each biome was built. Thanks for watching.